So, I'm back with our third lecture, which is First Law of Thermodynamics. So, what is basically First Law of Thermodynamics? In simple words, heat energy is converted to other form of energy, or other energy are converted into heat energy. Okay, let me write it. Heat energy is converted to other form of energy, and or not and but or other form of energy is converted to heat energy. Okay, so in simple words, when heat energy is converted to any other form of energy, or any other form of energy is converted to heat energy, that is simply called the first law of thermodynamics. And remember one thing, the total energy of the system before and after the conversion will remain constant. Let me note it down too, it's an important point. The total energy of the system before and after the conversion after the conversion will remain constant. Okay, remain constant. That's an important point to remember. Okay, and there is one more point, which is, first remember that thing, heat energy converted into any other energy, or any other energy converted into heat energy, is basically the first law of thermodynamics. And the total energy of the system before the conversion and after the conversion will remain constant, means there will be not any effect on the total energy of the system. Okay, and due to this law is a special form of law of conservation of energy. Okay, or you can say it's law of conservation of energy, or you can simply say this law, for example, this law is a special form of law of conservation of energy. Okay, I hope it's clear till now. Now let me just, for the mathematical term, let me give you an example which we have also studied in our last lecture, the lecture 2. Okay, if you know the lecture, so it might be so easy for you. So this is basically the piston. Okay, this is basically the piston, this is the layers. Okay, here we'll apply the atmospheric pressure. This is simply the volume of it. Okay, and this is basically the heat, delta Q, the heat which will be provide, and this is the internal energy 1, which is like the initial one. Okay, and here is the second system. Now what if I heat supply to the system? For example, if I supply heat to this system, So simply what will happen, the internal energy will increase and this pistol will go up like this. Okay, and here we have some work done. Okay, like the pistol have done some work. So in simple what we say that heat supply to the system delta Q, let me write it like heat supply to the system, heat supply to the system delta Q is equal to the increase in internal energy, which is denoted by Q, increase in internal energy of the system plus work done by the system Okay, so in simple words, the heat energy, okay, the heat means heat supply to the system. This is the system, this is basically the system, and the heat supply to the system is equal to the increase in the internal energy as the internal energy increased, and plus work done by the system. Okay, so mathematically we'll write it simply, which is so clear as we have the exact definition I've explained you, so it can be okay, so this will be mathematically okay. So the first thing is heat supply to the system, which is denoted by delta Q. Okay, heat supply to the system is equal to the increase in internal energy. Okay, is equal to the increase in internal energy plus work done by the system plus delta W. So this is what the first law of thermodynamics. This is simply first law of thermodynamics. Okay, now these three values can be positive and negative. Okay, so let me explain you the condition. Let's start with the delta Q, which is basically heat. So heat is taken as positive. Okay, heat, delta Q is equal to, okay, so it's taken positive, delta Q, okay, taken positive when heat is supplied to the system. Okay, taken positive when heat is supplied to the system, and delta Q is taken negative if heat is taken from the system. Okay, heat is released, you can write taken or released from the system, Okay, now let's come to, so in this condition, when the heat is basically you can say supplied to the system. Okay, when the heat is supplied, right here, supplied. Okay, when the heat is supplied to the system, so the delta Q is positive at that time. Okay, delta Q will be positive in that condition whenever you solve a question. And when the heat is basically released or taken from the system, delta Q will be negative. Always remember this thing. Okay, now towards the next, which is internal energy, change in internal energy. Okay, so internal energy is taken negative. Let's discuss positive first. Is taken positive if the internal energy of system increase. Is taken positive when internal energy of the system increase, okay, is increased, and it's taken negative. Delta U is equal to taken negative when internal energy is decreased. Okay, when internal energy of the system is decreased, whatever you want to write. Okay, now let's come to our last term, which is work done. So work done is taken positive if the work done is by the system. Positive when the work done is by the system. When the work done is by the system, it's taken positive. But when the work done is taken negative, in that condition, if the work done is on the system, okay, work done is on the system, in that condition it's taken negative. Hope so this is clear to you. And here's the first law of thermodynamics end.